Good afternoon everyone. Today we are going to study about BJT applications, and we have few more topics in module 4, which are feedback amplifiers and oscillators. Today we will be studying about some of the topics of module 4. You can see here the first topic is about BJT as an amplifier, BJT as a switch. So the transistor can be as a switch, making it an on and off, and you can also connect a transistor to an LED. You can also drive a lamp with the help of a transistor, but the only difference between the lamp and the LED is the lamp consumes more power with respect to the load, but not the LED. LED needs a normal, or we call it as a small cell, which can drive the LED, or 1.5, 2.5, or it can go up to 4.5 volts, depends upon what type of LED you are going to connect. Coming to the lamp, if you want to connect a 230 volts or 120 volts, 110 volts bulbs, you cannot directly connect to a transistor, because transistor works at very low voltages. To achieve this, we have named a particular device called as a relay. A relay will be used with the help of a transistor to switch on or switch off a particular lamp. Lamp is nothing but a higher voltages. So apart from these transistors, we have feedback amplifiers. In that we will be studying about principles, properties and advantages of negative feedback and also a positive feedback. So then we have types of feedback: voltage series feedback, gain stability with feedback, and apart from these feedbacks we have oscillators, Burkonian criteria for oscillators, and some are called RC phase shift oscillators. That is nothing but a resistor and capacitor coupled oscillators, and very famous Wien bridge oscillators, which I have already studied in physics. Apart from oscillators, we will be having some timers. When it comes to a timer, the very famous timer nowadays, if you see, a 555 timer, a very famous one. So whenever we speak about a timer IC, the preference is given to 555. Okay, so these are the topics to be covered in the module 4. So for the today's session, we'll be studying about module 4, the first two parts, the BJT as an amplifier and BJT as a switch. Okay, BJT as an amplifier. As you have learnt, a transistor amplifies current. It's all because the collector current is equal to the base current, which is multiplied by the current gain. So that is nothing but B. I'll come back to that. What is that? The base current in a transistor is very small compared to collector and emitter current. As you can observe here, the base current, that is nothing but IB, which flows through RB, and the current flowing through RC, that is nothing but IC. And the current, there is no resistance here, we are not specifying it. If that current flows to here, that is called nothing but IE current, the current flowing through the emitter. So IC, IB and IE. So here VC is nothing but here a correct output from the collector, and VB, that is a voltage difference between the base and the ground, common ground. Okay, next thing is, because of the base current is in transistor is very small compared to the collector and emitter current. See here, the base current is always smaller than your collector and your emitter current. It's a very small current which is needed to switch on the transistor to work in saturation region. I'll come back to what is that saturation region. Next, because of this the collector current is approximately equal to the emitter current. As you can see here, IC will be equal to IE, because IB is very small, which is we can call it as negligible. So that is the reason IC is equal to IE, approximately equal to emitter current. Okay, with this in mind, let's look at the circuit shown below. As we can see here, an AC voltage sinusoidal which is connected to the base of the transistor as an input, that's called Vs, is superimposed with a DC bias, through a capacitor, that's nothing but VBB. As shown here, we can see the AC voltage and a DC voltage which has become a superimposed to your base of the transistor, that's Vin. Okay, now the DC bias voltage, that's nothing but your VCC, is connected to the collector through which resistor? RC. So that's what which is shown here. Your collector is connected to RC with a DC bias voltage, that's called VCC. Your base is connected via RB with your VBB voltage, which is also connected through a capacitor through Vs, that's nothing but Vs is superimposed on a DC bias. Okay, we'll see how the amplification takes place. Because of there is a slight change in the input, there is a larger change in the output, that we can see, we will see in the next slide. Okay, let's see here. The AC input voltages produces an AC bias current, that is the minimum current required for the transistor to be in saturation region. So when there is a small change in input of your base, which results in much larger AC collector current, there is a small change in input, there is a drastical change in your output. So you can see the graphs here, the minimum voltage is here, the amplitude of the voltage is less compared to the amplitude voltage of the output, that's nothing but VCE and VC. VC is nothing but the voltage across your collector to emitter. VBB is the input voltage, which is nothing but your voltage from your Vs and VBB. Okay, the AC collector current produces an AC voltage across RC, thus producing an amplified but inverted reproduction of the AC input voltage in the active region of operation, as shown in the below figure. So if you can see here, the AC input of your transistor RB, there is a sinusoidal, that means it's an AC. So given to the base, will always replicate whatever the input you are given as an output, but there is a change in your output with an amplification of inverted output. That is how your base to, or we call it as biasing, base biasing we call it as, base to emitter. There are few more types of amplifications. Here will be the common with the input and output is your base, that's called as common base amplification factor. So input is common, here you can see one is the input given to the base, ground, again ground, again ground, again ground. But what is common from input output? That is nothing but your emitter. So common emitter configuration, this is also called as common emitter configuration, because the input and output is common for your emitter, or you can call it as emitter is common for input and output. Okay, next, the forward bias base emitter junction presents a very low resistance to the AC signal. when you come to forward bias, always remember, when there is a forward bias, there will be always very low resistance in the circuit. So when there is a forward bias, the base to emitter junction presents very low resistance. Here we can see base to emitter. So there is a what do you call it as the internal AC emitter resistance is low, thereby increased in your output, which you can see here. That's nothing but your RB. So there is a drastical change from the input to output. There is an increase in amplitude, but the only difference here is the inverted output. Okay, this is about an BJT amplifier. Very simple. So in the BJT amplifier, the common thing is emitter is common for input and output. Okay, we have few calculations here, some equations. Coming here for the first one, VB, so base voltage is equal to IE into RE. IE into RE. So for RB, the AC voltage VC equals to the AC voltage drop across RC. VC across RC will be equal. So VC is equal to IC into RC. What is VC? So if you see here, the current flowing through RC multiplied, that is IC into RC, performs VC. That's nothing but IC. If you say take IC, IC into RC gives you VC. That's what we have done here in the next slide. VC is equal to IC into RC. Ohm's law. Voltage is equal to IC into RC. RV is equal to I is equal to V by R. Since IC is approximately equal to IE, the AC collector voltage is VC is equal to IE into RC. Why it is approximately equal to IE? As we have studied, as RB is very less voltage compared to your RC and RE. R is not present here. I'm speaking about the current. The more the current which is flowing here from RC to RE, the collector IC equal to IE. The reason is IB is very less, which is negligible. Because it is negligible, so it becomes IC is equal to IB. So IC is equal to IB, IC is equal to IE, not IB. That is we have seen here, IC is equal to IE, because IB is very negligible. So here we are going to replace with IC as IE. So VC is equal to IE into RC. Okay, next, VB can be considered the transistor as input voltage, where VB is equal to Vs minus IB into RB. Okay, source voltage. What is VB here? The voltage for your transistor base. That's nothing but what? That's nothing but what here? VB, base voltage, is equal to voltage source, input source, minus IB into RB. Vs minus the current flowing through the base, IB into RB. If you do this, you will get VB. Okay, VB is nothing but Vs minus IB into RB. IB into RB is nothing but the voltage, because as for the Ohm's law, current into resistance is equal to V. Okay, so now coming to VC. VC is nothing but collector voltage. VC can be considered the transistor as output voltage, because see, the output we are taking here is at the collector. So when you take the output from the collector, that's nothing but your output from RC, we can say it as output voltage, the output voltage with respect to ground. So if you take the output from here, not from VCC, from this part, which is that this part, from here to here, if you measure by using a multimeter, there is an amplification from input to output. This is what we call it as VC. Okay. Okay, since voltage gain is defined as the ratio of the output voltage to the input voltage, what is the output voltage here? It's nothing but VC. What is the input voltage here? Vs. So what is gain? Gain is equal to output by input. Here output by input. What is output here? VC divided by Vs. So this is gives you gain. Okay. Now VC by VB, or we call it as Vs. The reason here is, here we are speaking about the voltage, as you can see here, VBB. Here input voltage is Vs, but when it comes to here, that is Vin. Vin is nothing but the voltage of your base, so that is nothing but VB. So you can take it as VB is nothing but the voltage of Vs minus VBB. So Vns minus VBB is nothing but, we call it as Vs is equal to, what is VBB? VBB is nothing but IB, the current flowing through that, IB into RB, or we can call it as VB, base voltage. Base voltage is nothing but the current flowing through the base into the respective resistance. So that is the reason we call it as VB. So here comes the ratio of output voltage to the input voltage. The ratio of VC by VB is the AC voltage gain, that is called represented as AV, voltage gain of the transistor. So this is the amplification factor of your transistor. Okay, now substituting IERC for VC and IERE for VB, which we have already seen here. VB is equal to I into RE and VC is equal to IC into RC. So these are the two equations we are going to consider, and we are going to replace it here. Then if you replace it, the gain will be VC by VB is equal to IE into RC divided by IE into RE. Okay, then you can see here the term IE cancels. It's same, right? So these things will cancel. So finally you will be resulted with gain RC divided by RE. Since RC is always considerably larger in value than the output voltage for this configuration greater than the input voltage, so always you can see here RC is always considerably larger, your gain will be larger with respect to input. So that is the reason it is called an amplifier. Okay, BJT is an amplifier. Here comes one small example for a BJT as an amplifier. Determine the voltage gain and the AC output voltage for the below circuit. You can see the circuit here. What type of configuration is this? This is called common emitter. That's called as CE configuration. Common emitter configuration. Why it is common? Because from input to output, what is common here? Your emitter is common, so it's called as common emitter configuration. Okay, so here we have some Vs input source with a coupling capacitor CC, I can call it as coupling capacitor of base, and we have some voltage VBB, we have RB and VB, and output V out is equal to, we need to find out. Then we have RC value 1 kilo ohm. 1 kilo ohm is nothing but 1000 ohms. It's nothing but 1000 ohms. VCC. VBB. So the voltage gain is given by, we know that V gain is nothing but approximately equal to RC divided by RE. So that is equal to, what is RC here? RC is 1000 ohms. That's nothing but 1.0 kilo ohm. What is RE here? We can see here it is 50. How 50? The question comes here. How it is 50? Usually the RE is the internal resistance of your transistor. That will be given by the manufacturer. So RE in this, they will be provided by in the exam. So RE value will be provided. So RE is 50 ohms. So 1000 divided by 50 gives you how much? You can calculate. It will be 20. 20 means what is this? Ohms and ohms get cancelled. So it will be nothing but 20. It's a gain. Okay. Therefore, the AC output voltage is V out is equal to what is this? Gain into VB. So what is the gain here? 20. What is VB here? 100 millivolt. So already they are given here. VB is equal to 100 millivolt. So what is this? 2 volts. 2 volts RMS. Root mean square. RMS means root mean square. So here determine the voltage gain and the AC output voltage for the given below circuit. What we have done here, we have found the gain. What is the gain here? 20. And AC output voltage for the below circuit. What is the AC? AC means RMS, root mean square, will comes into picture. So when it comes to AC, it is called 2 volts. So these are the problems based on your amplifiers. BJT as an amplifier. Okay, next is BJT as a switch. Next topic will be BJT as a switch. I'll be doing till here. Next topic will be continued in the next session. Switching operations. So we all know that transistor acts as a switch. Transistor acts as a switch. So what are the connectivity we have in a transistor? We have collector, we have emitter, and we also have base. Okay, so here base works as a switching which allows the current to flow from collector to emitter. So always VC will be approximately equal to emitter. So C is nothing but IC will be approximately equal to IE. So IC is approximately equal to IE means your IB will be very less. So that is the reason your IC is equal to IE. So if it is very less, there is a less current is required to switch on a transistor. So I can call it as a switch. There is a small force needed to switch on the transistor. As we can see here, when it is in cutoff or open switch, when I say about open switch, the input voltage, if you observe here, it is 0 volts. That's nothing but ground. Next, the collector voltage, that's nothing but your VCC, which flows through RC. So RC and RB. RB, the input voltage through RB. RC, the voltage for the transistor to be in switch on condition. So as per the Ohm's law, I can call it as VCC equal to RC into IC. V is equal to I into R, or I is equal to V by R. So when it comes to the input voltage here, when the input is 0, so there is no voltage here, there is no connectivity between collector to emitter. So as you can observe here, the switch is off. Okay, next coming to how to switch on the switch, or we call it as a saturation region. So if you want to make it as a saturation region, there should be an input voltage. So that is nothing but there should be a slight voltage, or we call it as current, so that IC will be approximately equal to IE. Slight voltage, slight increase in current for the input. So when there is a slight increase in current for your input, then your IC will be equal to IE. That is nothing but a short between your IC and IE. So to make it this as a short, or we call it as a closed switch, there should be a slight input voltage given to the transistor. This voltage is nothing but you can call it as IB into RB. So V is equal to IB into RB. So slight current is needed for the transistor to be in saturation region, or we call it as switch on condition. That is called switching operation. BJT as a switch. How the switch can perform as a open switch, or how it can perform as a closed switch. Okay, let us see once again how the switch works. Exactly it works. So transistor is also called as a switch. It's very popular. We call it as a transistor as a switch. So when there is no input voltage, the transistor will be in off condition. There is no flow of what? IC to IE. So IC, there is a current, but there is no path between collector to emitter. So if there is no path means the output is 0. So you can call it as output is equal to 0. So output is 0 means is nothing but open switch. The switch is open. So RC, RB, that's nothing but the resistance for your base and your collector. So the one more thing I need to tell you is this is an NPN transistor. NPN transistor. Okay. Coming to your closed switch. I don't need to explain too much for this. If you observe here, there is a current flowing from VCC to, or I can call it as IC and IE. If there is a flow of current from IC to IE, that means there is a slight increase in current, which is nothing but your IB. So IB is responsible for the current to flow from IC to RE. If it is flowing means it's nothing but there is a short between IC into RE. We should not say short, there is a path. So that is we show it in a switch pattern, saying that your collector to emitter is connected. So this is called as a switch. When the switch is closed, your transistor is in saturation. When the switch is open, the transistor is in cutoff region. So these are the two switching operations of your transistors. I am repeating it twice. It's a very important topic. Try to understand. So what type of transistors we know? One is PNP transistor and one more is NPN transistor. This is switched on by using a 0 volts. This is switched on by using a 1 volt. 1 volt is nothing but by digital. By analog it is 5 volts. In digital it is 1 volt. In analog it is nothing but ground. This is decimal. This is analog. So analog it is ground and 5 volts for the transistors will be in switched on. This is called saturation region. If the transistor should be in saturation region, for an NPN the input should be 1 or 5 volts. For a PNP it should be 0 or ground. Remember this, because it is negative triggered, because it is positive triggered. The center one represents the base, how the base is triggered. Here N means negative, here P is positive. So here I am speaking about NPN transistors. Okay, hope you all understand the topic today. So if you have any doubt, you can send me a mail or you can send me on WhatsApp. I'll be available on WhatsApp. Any queries with this, you can send me on WhatsApp. Okay, so thank you all for the session.